with in collections or in group. Then you talk about the most common one you might have come across during the course of your studies in other classes. Before this class would have been the base 2. Yes, conversion of base 2 and base 10. So I also have some of those examples here to help us refresh ourselves. So what I have here, I have conversion of bases and as well as some arithmetic questions involving bases. So without much time, let's go into it. So we're going to take in this question, convert 1101 base 2 to base 10. So how do we solve this question? It's not very, very complicated, okay? So we'll just write the number out. That's number 1. We have 1, 1, 0, 1 is 2. Now we have to convert this to base 10. It's not very hard. Now, each of these numbers will multiply them by the base, like 1 times 2 plus 1 times 2 plus 1, 0 times 2 plus 1 times 2. So let's do that. So the first thing we're doing is, firstly, we're going to say 1. 0 to the number where it stopped. So we have 0, 1, and you start from the right hand side towards left. 0, 1, 2, and 3. 0, 1, 2, and 3. So the last number here is 3. So this is just telling us that this is 2 raised to the power 3. 2 raised to the power 3. Right? This is 2 raised to the power 2, 2 raised to the power 1, 2 raised to the power 0. So solving this, we don't have this. We have 1 times 2 raised to the power 3 is just simply 2 times 2 times 2. So 2 times 2, 4, 4 times 2 is 8. So we have 8 plus 1 times 2 times 2, which is 4, plus 0 times 2 raised to the power 1, which is just 1, 2. We have 2 plus then 1 times 2. 1 times 2 raised to the power 0. And any number in according to indices, any number raised to the power 0 is always 1. So we now have 1 times 1. So from here, we now have 1 times 8 is 8. 1 times 4 is 4. 0 times 2 is 0. 1 times 1 is 1. So adding this, we then have 8 plus 4. That should give us 12. 12 plus 1 13 is 8. So with this we have successfully converted base 2 to base 10. So we are going to take the next example, which is convert 52 base 10 to base 2. Okay, so we are converting this 52 base 10 to base 2. Now how do we do that? We use the LCM method. Okay, use the LCM method. So I'm going to be doing the LCM method for this. I'll be using this part, although I may come back to clean the work so that we can have more space because we have a lot of questions here. So I have an LCM here, LCM table here, then I'll write my 52 here. Okay, then what am I using? What am I converting it to? I'm converting it to base 2. So I'm going to use 2 to divide it. So 2 in 52. So this 50 is 25. If you share it into 2, and this one is 1. So that's 25 plus 1 will give us 26. Then 2 in 26. 2 in 20 is 10. 2 in 6 is 3. 10 plus 3 is what? 13. Then 2 in 13. 2 in 10 is 5. Then 2 in 3 is 1. Remainder 1. So 5 plus the first one, we get 6. Then remainder 1. So we have 6 remainder 1. Here remainder 0 and here is remainder 0 because we didn't have any remainder for them. Then we now have 2 in 6. 2 in 6 is how many? Is 3 remainder 0. 2 in 3 is 1 remainder 1. then 2 in 1 is 0 remainder 1. So our answer will then be, you start from the bottom to the top. You say you have 1 1 0 1 0 0. So we are going to write this here, 1 1 0 1 0 0 base 2. So we have successfully converted base 2 to base 10. Okay. So we have successfully converted base 10 to base 2. Now moving forward, we have convert 31 base 5 to base 10. 31 base 5 to base 10. So now if you look at this one is like a normal number. So I have to convert it to base 10. Like I said, we still use the same method. Of converting. Now we have 3, but we have 31 base 5. Now we have to convert this to base 10. So we still use the same method. Now we have two numbers in 3 and 1. So we have 3 times, and remember, you are multiplying the number times the base that it carries. 3 times 5 plus 1 times 5. Then from the back you will say 0 and 1. Then from here we then say 3, then we combine 3 times 5. Remember, this 5 is raised to power 1. So 5 raised to power 1 is still 5. So 3 times 5 is what? 15. Then here is 5 raised to power 0. I told you any number raised to power 0 is 1. So 1 times 1 will now give us what? 1. Together they will give us what? 16 what? Base 10. So we have converted that to base 10. Then we also have number 4. Number 4 we have 24 base 5 to convert it to base 3. So this asks us to convert base 5 now. Asks us to convert base 5 to base 3. Now how do we do this? The first thing we need to do is that we need to convert base 5 to base 10, because 10 is like at the center of every other basis. So every basis can be converted to base 10 first before they can be converted to another base. Okay? So it's just like a train station where a train passes before it can get to where it's going. So the base 10 is like a train station. So this base 5 has to get to that station, which is base 10, before it moves towards base 3. So we have to convert this to base 10 first. So converting this to base 10, we say 2 times, remember, multiplying by the what? The base. 2 times 5 plus 4 times 5, 0 and 1. So we'll then have what? 5 raised to power 1 is what? 5. So 2 times 5 will give us what? 10 plus 4. Remember, 5 raised to power 0 is what? 1. So 4 times 1 will now give us what? 4. And together it will give us what? 14 base 10. So we can confidently change 14 base 10 to base 3. Now how did we do that? Remember when we change base 10 to base 3, base 2, we use what? LCM method. So we are going to use the same LCM method here. Mind you, are going to erase the working after this. Okay, so now we have 14, and remember what the base we are changing to is what? Base 3. So we are using 3 to divide this. So 3 in 14 is not difficult. Remember, 3 times 4 is 12, right? So it will remain 2. So we have 3 in 14 is what? 4 remainder what? 2. That's 3 times 4, 12 plus 2, that's 14. Then 3 in 4. How many 3 can we find inside 4? Is 1 remain 1. How many 3 can we find in 1? Is what? 0 remainder 1. And you must make sure that this place gets to 0. This place gets to 0. So now then take it from down to up. So we having what? 1 1 2. So 1 1 2 base 3. So that's the solution for that. Now going to question 5. They ask us to solve. Now, question 5 now is all about what? Arithmetics. Okay? We are solving arithmetics, addition and subtraction, multiplication and division of bases. So we have the first one. Okay? We are going to do it very neatly. We have the first one. We have 1 1 0 1. Then we have 1 1 0. I always advise my students to always shift their workings a bit, because if you bring it too close to this side, you will come into the line. So we are adding this base 2. Okay, so we are adding this. So it's just like normal maths, but anytime it gets to 2, because the highest number in base 2 is 1. So the only numbers are acceptable in base 2 is 0 and 1. In base 3, the numbers are acceptable is 0, 1 and 2. So it must not get to that particular number. So, but we have a way of converting it. I will show you that briefly. So we have 1 plus 0 is 1. 0 plus 1 is 1. Now 1 plus 1 is 2. And remember I told you that we cannot write 2 in under base 2. So what do? We have to convert this 2 to base 2. Because this 2 that we have is, we are solving it like base 10, so we have to convert it to base 2. So we now have 2. Remember I'm converting to base 2. How many 2 can I find inside 2? I can find 1 remainder 0. So I have 1 and 0. So in normal maths, if you have 2 numbers, you write this one down and you carry this one to the other side. So you then have what? 0 carry 1. I'm repeating the same thing. 1 plus 1 is 2. 2 into 2 is what? 0 remainder 1. This one, since there's no number here, we just bring the 1 down. So that solves that. So let's go to question 6. Now question 6 says that 1, that's 1, 2, 3, 4, 5. Okay? So 1, 2, 3, 4, 5 minus 1, 1, 0, 1. 1, 1, 0, 1. Remember, always arrange your numbers accordingly. So we have this 2. So we are subtracting. So 1 minus 1 is 0. 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 1 is 0. Then bring down 1. Since we don't have 2, we are not converting anything. Okay? So now we are done with this. So I also give you another example which I believe will also help us to understand, because not all that are like that. So we have 1, 1, 2, 3, 1 minus 1, 1, 0, 1. Now this one, the working of this one will be different from this one, because this one at some point we have to carry. Okay? So now we have 1 minus 1 is 0. 0 minus 0 is 0. Now if you look at this place, can you remove 1 from 0? No. You go to the next number. Can you borrow from here? No. So you come to 1. It's from 1 you borrow. So if I borrow from here, what am I borrowing? Remember we are doing base 2. So the number that we are borrowing is 2. When we do normal maths, we are solving on that base 10. So when they tell you that something like this, they say 7 minus 1, you say it's not possible. So you borrow 1 from here, become 11, right? This 11, they cannot tell me that 1 plus 1 is 11. No, this one is actually a 10 because it's base 10. So now the same thing we are doing here, we are actually carrying what? 2, because we are doing base 2. So if I carry 2, if I borrow 2 from here, this 0 now becomes 2. But is this way I want to solve? No, this is where I want to solve. So I'll still borrow from here. Here now become 1. Then here become 2. Then 2 minus 1 will then give us 1. 1 minus 1 is 0. Then this one is already cancelled, so 0. So this is our answer, base 2. Number 8. Number 8 we have multiplication. Okay, 1, 1, 1 times 1, 0, 1. So we have, like I said, shift your hand to this, because multiplication always tends to go this direction. So I have 1, 1, 1 times 1, 0, 1. So let's multiply this. 1 times 1 is 1, just like normal maths. 1 times 1, 1, 1 times 1, 1. 0 times 1, remember 0 times any number is 0. Then 1 times 1, 1 times 1, come under here 1. 1 times 1, 1 times 1, 1. Then we'll add. Here is now 1. Here is now 1. Here is now, remember, we are doing base 2. 1 plus 1 is not 2, is 2, but you can't write 2 down. So remember what we did, we converted it and we have 1 remainder 0. So write 0 down and carry 1. 1 plus 1 is 2 again, so that's 0, carry 1. 1 plus 1 is 2 again, that's 0, carry 1. Remember, there's no number repeating that 2, so bring it down. So we now have base 2. So this is our final answer. Then for number 9, which is the division. For number 9, which is the division, we have 10 110. No, this is base 2, so we call it 110. Okay, so we have 1 0. We have now for us to do this, yes, for us to do this work, there are two methods. We can use long division method, okay, but to make this class very easy for us, we are going to be using the conversion method, where we convert this to base 10, then we divide it as base 10, then we'll now convert it back to base 2. It looks like a long journey, but it's something that's very easy to do. So we are going to start here from and we likely go to this particular space. Now we have 1 0 1 0 1 0. Okay, so we want to convert this to base 10. We also convert the 110 to base 10. So this is base 2. And remember, we then multiply by 2. So we now have what? 1 times 2 plus 0 times 2 plus 1 times 2 plus 0 times 2 plus 1 times 2. So I think these are the numbers. 1 2 3 4 5 6. 1 2 3 4 5. Okay. There's still that 0 times, that's from here, this is 1, then we have 0. 0 times 2. So start from the back. 1 2 3 4 and 5. So here we now have 2 raised to the power 5, and like I said, it doesn't mean 2 times 5, it means 2 in 5, 2 multiplied in 5 places. So 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32. So we have 32. So we have 1 times, let me shift a bit here, 1 times 32 plus 2 raised to the power 4 means 2 times 2 times 2 times 2, which will give us 16. So you can do that math. 16 plus 2 raised to the power 3 means 2 times 2 times 2, which will give us what? 8 plus 0 times 2 raised to the power 2 means 2 times 2, which is 4, plus 1 times 2 raised to the power 1 is what? 2, plus 0 times 2 raised to the power 0 is what? 1. So we have to find the value of this. So let's solve this. 1 times 32 is 32, plus 0 times 16 is 0, plus 1 times 8 is 8, plus 0 times 4 is 0, plus 1 times 2 is 2, plus 0 times 1 is 0. So add everything together, then we have 32 plus this is 40, 40 plus 2 is 42. So this is 42 base 10. So we have to do the other one, which is 110. So let me do that one here before I go over there. So we have 1. Okay, I'll just put this as B and this as A. Okay, 110 base 10. We now give us what? 1 times 2. Sorry, base 2. Now give us 1 times 2 plus what? 1 times 2 plus 1. 0 times 2. So we have 0, 1, and 2. So from here we now have 2 raised to the power 2 is 4. So we now have 1 times 4 plus 2 raised to the power 1 is 2. 1 times 2 plus 2 raised to the power 0 is 1. 0 times 1. So we then have 1 times 4 is 4 plus 2 plus 0. So this will now give us what? 6. So we have converted them to base 10. So that means this 42 and 6 is just our normal number. So what we are just doing what? 42 divided by 6. Just like this divided by this. So okay, so let's do that. So we have 42 divided by 6. So I'll be using long division method. Okay, so we have the solution 42 divided by 6. Okay, let me use fraction method. Okay, so I have to share this. Okay, I can say 2 here 2, it give us 1. So that will give us 21. So that's 21 over 3. How many 3 can go in 21? It's simply what? 7. If you check your multiplication table, 3 in 21 is 7. So we have to convert this 7. Remember, we have to solve it in base 2. But this 7 is in base 10. So we have to convert this 7 to base 2. Now how do we do that? Like I said, we use the LCM method, converting base 10 to another base. We use the LCM method. So we write 7 and write 2. So how many 7 can go in 2? How many 2 can go in 7? That will be 3 greater than 1, which is 6. Then 2 in 3 will give us 1 greater than 1. 2 in 1 is 0 greater than 1. So we have 1, 1, 1. Okay? So we then have 1, 0, 1, 0, 1, 0 divided by base 2 divided by 1, 1, 0 base 2 is equals to 1, 1, 1 base 2. So these are our final answer. I hope this class has been educative, and consequently this is my first video ever, but consequently I'll be doing more videos so that we can progress together and learn a lot of things. So I'm taking GSS Mathematics for this first section. Please, I would like you to share my videos to encourage me to do more, and I would also like you to subscribe to have a lovely day. Thank you.